If you're using GitHub Actions and you want all the benefits of GitHub's hosted runners rather than self-hosting your own and having to manage your own, but you still need to connect to private networked resources that are behind an Azure virtual network or maybe even on-premises in a hybrid connectivity solution, then keep watching because this is the video for you. GitHub have released some pretty cool functionality that's been in preview for a little while, and it's now made its way to being generally available. And I want to take you through it here. And as usual, there are chapters down below if you want to bounce around, totally understand that. But I want to start with a little bit of the theory. We'll do a whiteboard and show what the problem is and what we've done historically with self-hosted runners, or even worse, opening things up to the public internet, and then talk you through what the new solution looks like. And then we'll jump into the lab, we'll go end to end with configuring it and testing it out. So let's get started. I want to start first of all by talking about what problem is it that we're trying to solve. And if you look at this pretty basic architecture here, over here on this right-hand side, there's an Azure Key Vault, and that has got a private endpoint on it. So at this point in time, and this is what my lab environment looks like as well, that Key Vault is only accessible through that private endpoint. So it is denying all public traffic, and there's nothing allowed through the public firewall to access that Key Vault. That is, of course, attached to an Azure virtual network because the private endpoint needs to be on a subnet, which is inside of an Azure virtual network. And then over here on the left-hand side, we've got GitHub Actions. So you might have an action, and in my demo example here in this environment, I've got a GitHub action that I want to use to retrieve a secret from that Key Vault to then use somewhere else in my Actions workflow. And I'll take you through the action in just a moment. We'll go and have a look at the workflow that I've got in my repository. But what happens right now is this GitHub Actions would run, and it is going to then run on the GitHub Actions runner service, which by default is going to be a GitHub-hosted runner. So that's a virtual machine or a container that GitHub manage the image for, they're managing the provisioning of, and you're just using it as a service effectively. So when it runs there, it's going to try and access my Key Vault, and it's going to use DNS to look up the endpoint of that Key Vault. And even though it's got a private endpoint, it will still look up the public address. So what's going to happen is this runner is going to try and connect to the Key Vault, but it's going to try and do that over the public internet and connect down to here. And what's going to happen is that even though this has got a firewall on it, it's not allowing anything through that firewall, and we've denied public access into the Key Vault. So this is not going to work at all, and our workflow is going to fail, and it's going to say there's no access to this Key Vault via that path. Now, if I jump over here into GitHub, actually, let's have a look at the Actions workflow first that I've got here in Visual Studio Code. And all of this is in the repository. It will be linked below if you want to come and have a look at what I've got. It's nothing too fancy, it's just something that I've whipped up for this demo. So first of all, it is a manual trigger, so on a workflow dispatch, so that I can trigger it here in the GitHub Actions portal. And I've got a few inputs just to make my life a bit easier. So I've got an input called secret name, so what's the name of the secret that I want to retrieve from the Key Vault? And then also what is the name of the Key Vault? And I've got a few default values here you can see. So my secret is called my super secret. And my Key Vault is called gh-runner-demo-kv-001. Now, those are just default values. You can use this if you want, or you might have another scenario that you want to work through. Down here on lines 15 through 17, that is just some code in there to allow the OIDC connection from GitHub Actions to access my Azure environment. And then as I scroll down here, I've got a job, which is pretty straightforward. Now, the first thing to call out is this is running on Ubuntu-latest. So that is a GitHub-hosted runner running Ubuntu. It's nothing that I've got. It's nothing that's self-hosted. It is just using the GitHub service to run this job. And then underneath steps, we've got some pretty basic steps. So I'm going to check out the repository, and then it's going to do an Azure/login to actually authenticate me to my Azure environment using my subscription client ID and tenant ID using OIDC. And then as I can continue scrolling down here, these are the jobs that are of interest to us. So there's one here to retrieve the secret from Key Vault. So all it's doing is using Azure CLI to run AZ Key Vault secret show, and then I'm passing in the name from the inputs that I had above to give it the name of my Key Vault and also the name of the secret that I want to retrieve. And then it's dropping that into the GitHub environment variables. And then down here in the last action in this workflow, I'm simply displaying that on screen. Obviously, you wouldn't want to be displaying this, but this is for demonstration purposes only. to show that I've been able to retrieve the secret value and I can show it on screen. Normally, of course, you'd then do something else with that secret value. You wouldn't display it on the screen. That's all my workflow is doing. And really, it's just to demonstrate the purposes of accessing a resource. In my case, that's the Azure Key Vault, using a private endpoint through this connectivity that we're going to set up. So that's the workflow itself. Now, if I jump into the GitHub portal and we go into Actions, I ran this a little while ago, 40 minutes ago, and if I go into the job, we can see that it did indeed fail. And this is because, when it scrolls down here, this is because, it's, as it says here, it was forbidden, and the connection is not an approved private link, and the caller was ignored, the caller being the GitHub Actions runner, because bypass is not set to Azure services and public network access is set to disabled. All that really means is that the runner that was running my GitHub Actions, the GitHub-hosted runner, didn't have access to go and access my Key Vault. It was access denied because I'm only allowing access through the private endpoint. So that's kind of the scenario that we've got set up here, and the demo environment as well. If I jump across to my Azure environment in this resource group, you can see here, all I've got is a Key Vault with a private endpoint, and of course, a virtual network for that private endpoint to go onto, and a private DNS zone, so the DNS resolutions will work okay for the private endpoint. And also, if I just jump onto my virtual network here, something to be aware of is I do have two subnets. You can see I've got subnet-001 and subnet-002. And if we look at connected devices, the private endpoint for the Key Vault is on subnet-001. So if I jump back over to the whiteboard for just a moment and we have a look at this again, what could we do before? And there were a few things that I've seen that are kind of workarounds, and they don't really keep the resources in a secure state. And those were things like allowing the GitHub ranges for the hosted runners through a firewall. So on that firewall that we've got on the Key Vault, you might have either temporarily or permanently allowed the GitHub IP addresses, or for the hosted runners specifically, so it still went through the public interface to access that resource, so it wasn't as secure as leaving it fully private. And similarly, I have also seen, and also done myself a few times, where you actually, in your workflow, you will get the IP address of the specific runner that you're using for that point in time, and then you have some code in there to get the IP address, go and punch a hole through the firewall for the resource that you're trying to access, do the things in your workflow or your pipeline that you need to do, and then go ahead and remove that rule from the firewall. But again, it is going through the public internet, and it is opening up that resource to the public internet, which is not really what we want here. Thirdly, just as another workaround, but it's in the same boat, is that with GitHub, you can also specify to have a static IP address for the runners, but it's kind of the same solution or the same situation. You're still opening up public internet access to an IP address or some sort of range and allowing access in through the public internet, and all of your traffic is not staying private. So the one real solution to this was to use what's called a self-hosted runner. So if we jump back to the whiteboard here and have a look, what you would normally do is in this Azure virtual network or another virtual network that's peered and can access that private endpoint, is you would go ahead and you would deploy a virtual machine or a container. You can run self-hosted runners on either a VM or a container. And that would, of course, have a NIC, a network interface card, and that NIC itself would be attached or it would sit on some sort of subnet. And that subnet might be on the same virtual network, or it might be a different one, like I said, and on a peered network. But effectively, what happens here is now when you go to run your GitHub Actions, instead of running on the Actions runner service and those hosted ones, the workflow would actually run down here on this virtual machine or this container in your environment, whether that be on your Azure virtual network, or if you're running on premises, you might have had a virtual machine running in a VMware solution or something like that. Now, what happens here is because this virtual machine is running in your environment, it has access to the private endpoint, so it can now traverse the virtual network or the subnets and access this private endpoint and access the resource that you're trying to get access to. Now, there's a few things with that, and this is still totally a valid solution. There are situations where you might want to run your own builds or releases on self-hosted runners, and that's absolutely fine. You might have some custom images that you want to run with some custom software that you don't want to install every time you run a workflow. You can run your own, but it does mean you've got that maintenance overhead. You've got a virtual machine to manage, or a set of virtual machines, or a container platform. The auto scaling has been a little bit of a pain point. Basically, for virtual machines, there's no built-in auto scaling solution. So if you're running a lot of GitHub Actions workflows on self-hosted runners, your auto scaling, you'd have to basically home bake something yourself at this point in time. There is a solution for running on a container-based system and having auto scaling with that, but it does mean deploying AKS, which some customers may or may not want to do just for the sake of having the self-hosted runner and the auto scaling capability. So that's kind of where we've been today, between self-hosted runners and this compromise of opening up public internet access for hosted runners to be able to access resources. But now with this new functionality, there's something else that we can do that is a lot more secure. So if I scroll down to a new diagram here, this is now what this new functionality brings. And the key thing here to note is that what we can do now is that we can actually integrate the GitHub Actions hosted runners with our Azure virtual network. So if I have a look over here, this time, if we were to run our GitHub Actions workflow, we can tell it to run on GitHub hosted runners. Oops, my pen went a bit crazy there. It can run on the GitHub hosted runners, but this time with this new functionality that we're going to work through the configuration of here in a moment, the way in which this works is it actually deploys a virtual network interface card over here on your subnet on one of your Azure virtual networks. Now, this could be the same virtual network that your resources are on that you want to access. It could be on a hub virtual network in a landing zone hub and spoke model. It could be also deploying to a separate virtual network that you've gone and deployed just for GitHub hosted runners. It doesn't matter too much. It comes down to your architecture, what your Azure environment looks like, and where you'd want these interface cards for the hosted runners to be integrated with. Now, one of the key things to note, and this is really cool, is that because it's on an Azure virtual network, it also means that it's going to take into account any rules that you've got. So things like network security groups or any user-defined routing or network security policies that you've got on that subnet, the GitHub hosted runner will abide to. So you can control the policies, you can control the network flow, you can control ingress and egress out of the subnet that's being used for this, but you can still make use of the GitHub hosted runners. You don't have to worry about images, you don't have to worry about keeping things up to date, you don't have to worry about hosting virtual machines or running a container platform for this. You can still leverage it all as a service, get integration with your Azure virtual network to access those resources. And all you've got to really deploy for this is a subnet on a virtual network somewhere and make sure that you've got rules in place for the network traffic. That's pretty much it. That's what it comes down to. Now, it looks pretty simple and it's not that complex at the end of the day, but there are a few things to be aware of as we go through the configuration of it. So let's start with looking at quickly how this works from a documentation point of view, and then we'll jump into the demo and start configuring this. So if I go over here and there's a page, again, I'll link all these resources down below so that you've got easy access to them as well. This page here is about Azure Private Networking for GitHub hosted runners in your organization. And there's just a few things that I wanted to specifically call out here. The first one, in fact, is that the way in which this works is it uses what they call larger runners. This is something to be aware of from a billing point of view, and I'll reiterate this when we get to the configuration stage as well. But with certain packages and plans of GitHub, you get included minutes. So on the free plan, I think you might get 2,000 minutes. I forget the exact. On the team one, it might be 3,000 minutes, and on the enterprise, it's something like 50,000 minutes of GitHub Actions runtime. Now, that is all good if you're just using the default pool from GitHub and their standard runners. But because these are larger runners, basically this means that you'll pay per minute for these particular runners that are integrated with the Azure Virtual Network. So it won't draw down from that prepaid or that free allocation that you get in your specific plans. Just something to be aware of. Now, as we scroll down here, there are a few things that I wanted to make you aware of. There is a diagram here from GitHub. Whoops, I didn't mean to open that up. There is a diagram here that shows basically what I just went through, but as a step-by-step, this is how it works. So first of all, a GitHub Actions workflow is triggered. The GitHub Actions service creates a runner, so that's all on the GitHub side of things. And then the runner service deploys the GitHub-hosted runner's network interface card into your Azure virtual network. The agent then picks up the workflow job and it queues the job, and then the runner still sends its logs back to the GitHub Actions service. So you don't need any logging internally within your Azure environment. It still sends that outbound traffic back to the GitHub Actions service. And then the NIC accesses on-premises resources. So what's interesting here is in this diagram, will it let me open that up? No, it won't. If I scroll in a little bit, you can see here that this is the customer Azure Virtual Network over here on this side of things, and it's got the network interface card there. But if I scroll up a little bit, if you've got something like an express route or a VPN connection, as long as there's connectivity between the Azure Virtual Network and somewhere else, maybe a hybrid IT environment that's on premises, you can also access those resources because it's just going over your network. So any rules that you've got in place to allow the network interface card in the specific subnet in Azure, it's going to work. So you could use this to access on-prem environments or other hybrid environments as well. One thing worth calling out as we scroll down here is the supported regions as well. So when this service came out, there were, I think, 3 supported regions. And what is there? There are probably about 12 now in that list of supported regions. One thing to bear in mind is that if your region where you primarily run your Azure environment isn't listed there as a supported region, well, it's not the end of the world because you could deploy a virtual network in one of these supported regions for the GitHub integration and then do VNet peering across to your environment. Now, you would want to keep in mind how much bandwidth is going across that because you have ingress and egress charges within the Azure environment itself if you are traversing across different regions. But for the most part, for build and releases and all of that sort of stuff, hopefully it shouldn't be too much traffic that is going across there. So if that was a barrier for you right now where one of your regions aren't supported, you might be able to work around that by deploying the GitHub integration into a supported region and then doing VNet peering across to your main environment. There's some information here about the GitHub Actions service permissions that are needed to be able to deploy that NIC and join the NIC to a subnet. And as I said before, it does use your virtual network's network policies. So network security groups, any user-defined routes, any policies that you've got on it will apply to the GitHub-hosted runner's virtual interface card that gets connected to your subnet. So that's pretty much it from the overview documentation point of view. And there's one extra thing that I wanted to call out really specifically before we get into it. And during the preview of this functionality, it was only available if you were a GitHub Enterprise Cloud customer on that enterprise plan. But thankfully, they have made it available for any customers that are on the GitHub Teams plan as well, which is much more cost effective. And there are a lot of our customers that are running GitHub Teams because that meets all the functionality for them. And I was really glad to see this functionality also be available on Teams as well as Enterprise. So just something to be aware of. If you are a GitHub Teams user, you do indeed have access to this functionality. Hey, this is Future Matt, and I'm just interrupting you quickly because what I noticed when I edited the video was that I showed you everything in the demo that was around a GitHub organization and where the settings and configurations are if you've just got an organization. Now, if you're an enterprise customer with GitHub Enterprise, you will have something called a GitHub Enterprise, which kind of sits above organizations in the hierarchy. And what I wanted to point out was on screen here, I've gone into my account and I've gone to enterprises, and this is an enterprise that I am a member of. And I wanted to call out that while the settings are pretty much the same, if you've got an enterprise, you don't do the configuration on the organization level like I'm going to show you through the demo. You would in fact come here to the enterprise, come down to settings, and you'll notice that the hosted compute networking option is here at the enterprise level. So this is where you would go through the network configuration. And similarly, I think it's underneath policies maybe. It is, yep, you'd come into here and actions. and this is where you do the runner and the runner group configuration. So it is all the same as per the demo and the rest of this video, but just be aware, if you're a GitHub Enterprise customer, you do all of the configuration at the enterprise level. You won't find it at the organization level like I'm going to have in the rest of the demo. But if you're a GitHub Teams member and you've just got an organization and you don't have enterprises, then the rest of this demo is valid in terms of exactly where you'll find it. Just wanted to call out that little nuance. But yes, if you are an enterprise customer, the rest of this video is still absolutely applicable. It's just that the settings are here at the enterprise level, not at the org level. So when we talk about how this works, from a high-level process, we start by setting up and configuring the Azure environment. And GitHub have published a few scripts to help with this. We'll work through all of that in just a moment, but there is some configuration to do. Now, in my example that I've got in the lab, I wanted to simulate already having an environment. So I've got a virtual network already, as you saw. I've got some subnets. I've got a key vault that's got a private endpoint. The scripts that GitHub provide do go ahead and spin up a virtual network and a subnet, but I'm going to comment them out in my version of the script. You'll need to adjust it for your environment, and whether you're doing testing or actually deploying it for real, you might want to tweak how this is done and go through that process there. Step number 2, once we've got our Azure environment in order, is to go into GitHub and create the network configuration in GitHub. After we've done the network configuration, we then need to create something called a runner group in GitHub, and we specify within the runner group that needs to use the Azure network configuration that we just would have configured in the previous step. And then inside of that runner group is where we then create a runner and associate it with that newly created runner group. And that's where we go ahead and create a runner. We tell it that it is still a GitHub-hosted runner, but we want to have one of those larger runners that we spoke about and integrate it with the runner group that we just created, which in turn gives it access to the Azure network configuration that we created in the step before that. Lastly, when you've got all of that out of the way, you can then update your GitHub workflows to use the new runner that we just created rather than the default runners that GitHub have, so that it can access our private network and our private resources. So with all of that out of the way, I think we're good to jump into the demo. You saw how it's set up at the moment and that it failed. I'll walk you through a few of the scripts and documentation that GitHub have. We'll go ahead and set this up, test it out, and see how it goes. Now, within the repository that you'll be looking at here, let me close that YAML file. We don't need that anymore. This is the repository that I've got that I'll publish alongside this video. And I do have a bicep template in here, which is called deploy-demo-environment. Now, this is just a bicep file that I wrote pretty quickly, to be honest, that deploys the environment that you've seen over here in the portal. So it just deploys these resources that we've got here. So things like the key vault, the private endpoint, the virtual network, so on and so forth. It is 100% up to you whether you want to use this or not. I thought I'd include it because, well, it can't hurt to. But just a few things to call out as we go through this very quickly. I do have some key vault role assignments that I've assigned here. These are going to be specific to me. These two things here, these principles, one of them is my user account, and the other one is a service principal for the service principal that I'm using to connect GitHub Actions into my Azure environment so that it can read from the key vault. So just be aware they are specific to my environment, those two things. As I scroll down here, I created a resource prefix just called gh-runner-demo, so you'll see that reused throughout the naming of the resource. And then I use the Azure verified modules, the newly created AVM. That's great, by the way. If you're using Bicep, go and check out Azure verified modules. I might have to do a post or a video on those as well, but there's plenty of resources out there already. So I didn't write any of this Bicep. How great is that? So I'm just deploying a resource group here. Then I'm going and deploying a virtual network down here. Couple of subnets on that virtual network. The first subnet that I've got is where the private endpoint is for my key vault. The second subnet is going to be the one that we're going to delegate to the GitHub Actions service. So you need to create an entire subnet for the GitHub Actions service. That is just something to be aware of as you go through this. Down here, I've got a private DNS zone that I created for the private endpoint functionality to work. And then lastly, we've got the key vault down here. And it's worth calling out that during this, I am also creating a secret called my super secret, and the value of that I'm passing in just through a secure parameter. So when I deployed this environment, I punched in a random string there, for the secret value. And we'll see what that is should this all actually work and print that secret value for us back in the GitHub Actions workflow. So that's pretty much it. I just did want to call out that I do have a bicep file there for deploying the environment if you want to. And then the workflow, we've already gone through and seen what that does. It's basically just accessing the key vault and displaying the value of a secret. That's all that is really doing. Let's jump into the documentation again real quick. And this page is configuring private networking for GitHub hosted runners in your organization. And there are a few prerequisites. So first of all, you need to use an account with the subscription contributor role and the network contributor role. To correctly associate subnets with the right user, the Azure Network Settings resource must be created in the same subscriptions where your virtual networks are created. And then they've just got a general comment here to ensure resource availability / data residency. Resources must be created in the same Azure region. And then they go on to say to save the following .bicep file as actions-nsg-deployment.bicep. So as I scroll down here, this is what they're referring to. So they have given us a bicep file, which I've gone and saved, and it's a bit easier to look at here in Visual Studio Code. So I've called it actions-nsg-deployment.bicep. And I just want to go through this relatively quickly. There's not a lot going on in here. It's simply deploying a single network security group. And what it's doing is it's putting in some rules in that network security group. So the first rule that it's got here is to allow the VNet outbound override. So that is allowing access out to other virtual networks on port 443. And we can see it's allowing their outbound. And then if I keep scrolling down, the next rule is to allow outbound actions. So this is going out on port 443. And this is going out to a range of IP addresses. So this is the GitHub Actions service. So it's allowing through the NSG, where the virtual network interface card for the GitHub runner will be connected to, it's allowing outbound traffic to go back to the GitHub Actions service with this rule. And then with the subsequent rule here, they've got another one for allow outbound GitHub. So again, port 443, a range of IP addresses to get back out to the GitHub service itself. That's probably for things like logging and some connectivity that it needs to do as it's establishing the initial connection with the Actions service and such. And then there is also a rule to allow storage outbound as well. And then they've got a deny in here. So this is pretty important because I came across an issue that I want to make you aware of. So this rule here, this last one, is a deny internet outbound overwrite rule. So this is simply anything that is outbound towards the internet, it's going to deny. And these rules all take precedence over the default network security group rules that come when you deploy an NSG. Now, this one here is important, and I want to make you really aware of this because it took me longer than I'm proud of to admit to figure out what the issue here was. But if I jump back real quick to my GitHub Actions workflow, and this will probably be similar for a lot of people who are doing this integration, is that you probably want, as I scroll down here, to log into your Azure environment somewhere in your workflow. For me, I'm doing that with Azure CLI. You may not always want to do this. Some of your deployments to private networking might just be copying some blob storage or doing something like that. But more often than not, I think you'll want to log into Azure. Now, with that default network security group rule in place to deny outbound traffic, it's also going to deny this from working because this is connecting outbound to Azure to authenticate. And my workflow was failing and I couldn't quite figure out why. And I'm like, of course, there's some network security group rules in place. So just be aware of that. If you copy and paste the NSG rules from GitHub, that is going to be there and it's going to deny outbound traffic. So what I'm going to do is I'm going to, oops, what did I miss there? I'm going to comment that section out in this bicep code. So I'm not going to deny the outbound. I could go and get the addresses for the Azure service and put them in there as a rule, which is probably what you'd do if you go and put this in production. But just for now, I'm going to let the GitHub Actions service go outbound through my Azure virtual network to the internet. That's absolutely fine. So I'll save that bicep file. So that is just something to be aware of. They do provide a bicep template for you to deploy a network security group. Now, you don't have to use that, but they do recommend that you obviously control traffic in and out of your subnet where these are connected to. And the other thing that's worth noting, this is called out in the documentation somewhere, is that this service doesn't need any inbound traffic. So you can block all inbound traffic to this subnet where the network interface cards for the GitHub hosted runners are going to be deployed to. There's no reason for any traffic to come into this subnet. It is all outbound traffic from here. As I scroll down past that bicep template, the next thing that we need to do is to obtain the database ID for your GitHub organization, because we'll need this in just a moment. Now, I wish this was just available somewhere in the GitHub user interface, but alas, it's not. So you need to either jump in with GraphQL and run this query that they've got here to go and retrieve your database ID, or alternatively, you can just do a curl to a specific URL and retrieve it from there from the API, which is what I'm going to do. But to do that, we need a personal access token so that we can authenticate to the API. The reason that we need the database ID will become obvious in a few moments, where we go to deploy or configure some Azure resources. And it's effectively by using this GitHub organization database ID that we're saying we allow the GitHub service specifically for the organization with this ID to access and join and use our Azure virtual network. So it's kind of allowing it, and this is the component of that that's allowing GitHub to actually connect to the Azure virtual network. So let's go ahead and we'll jump over to GitHub and we'll create a personal access token. So in my user account, I'll come down here into settings and then scroll down on the left-hand side and under developer settings, go to personal access tokens, and classic token will be fine. I'll generate a new token here. And I am filming this on my mobile device, so I can't use that. I'll need to use my Authenticator app. Bear with me a moment. Good old 2FA. Hope you've got it enabled. Okay. What do we need here? So we need a name for the personal access token. I'll just call that one GitHub Runner Demo. We can set it to expire in 7 days. That's fine. I'll delete it after this video before it's posted to the internet. So you can try if you want, but it won't work. And the only thing that we need is under admin org, we just need read privileges to be able to access this. That's all. So I'll generate the token here. And I'm going to copy that token because if we navigate away from this page, we can't see it again. And over here in Visual Studio Code, I've got the curl command that was in the GitHub documentation there. So we need to drop the token in at the top there. And then we also need the organization name, so it knows what to look up. The organization that I'm using in this demo is just simply mattorford-org. So with that, if I bring up a console here, let's go to the terminal and PowerShell will be fine. We'll copy and paste that into there. We will paste it as one line. That should be fine. And there we go. Oops, let me get rid of that panel on the left there. But you can see here, I got the response. This was the response from the API down here, and specifically over here is the database ID. So that is what we need, and just copy and paste that for a moment because we will need it here in a few moments where we run another script and deploy a few more resources into our Azure environment. We need to specify that database ID. So I'll grab mine here and just paste it off to the side. Clear the screen there. So we don't need that personal access token anymore. That's all good. If we go back over to the documentation, the next section or the next thing that we need to do is, as per their documentation, is to use a script to configure your Azure resources. Now, this is expecting that we have downloaded the bicep file that was mentioned previously and called it actions-nsg-deployment.bicep. And there's a few things that we need to provide. And it just says here, when setting your Azure location, you need to use the region's name. So to specifically get that, they do provide an Azure CLI command there to get the specific string that you'll need for the Azure region. And when you create the network settings resource, which is what we'll do in just a moment, a service association link is applied to the subnet that you provide. And I have tested this and it does prevent accidental deletion of the subnet while it's in use by the GitHub Actions service. So if you go to set this up and then want to tear it down and set it up again, just be aware that once you've done the configuration inside of the GitHub side of things, it will kind of lock the subnet in Azure and not let you delete it. So you need to remove the configuration within GitHub, which will release the lock on that subnet in Azure, and then you can delete the subnet or the virtual network or whatever you want to do over there. Now, it does say here in the last bullet point that if you customize this script to use network resources in existing subnets, which is exactly what I've done, you must ensure any NICs connected to the subnet are deleted because it wants to delegate that entire subnet to the GitHub service, like I mentioned before. So as I scroll down, they do provide a bash script here. And look, this is okay. I know this is new functionality. I think I would love to see either a script that is more flexible in terms of accepting some parameters, or probably even some infrastructure as code to deploy these things with some conditional logic. And what I mean by that is, I'll scroll down here a little bit. I have got a PowerShell version of this as well, but they've got some environment variables, so it's expecting you to put things in here in this section. So it's wanting you to put the name of your virtual network and your subnet and a resource group and your subscription ID, so on and so forth. And then as we scroll down, some of the things that it does is it will log into the Azure environment. It will then register the resource provider. It creates a resource group. It creates that NSG using the bicep file that we saved a few steps ago. It goes ahead and creates a virtual network. It delegates the subnet, so on and so forth. So it's creating the VNet, it's creating the subnet, it's creating the resource group. But I think that with a well-written piece of infrastructure as code, this could be a lot more conditional. It could accept inputs. You could say, hey, I've got an existing virtual network that I want to deploy this to, and here's the VNet name, and here's the subnet name. And then within conditions there, it could just use those rather than try and deploy new ones. So anyway, it's early days. That might come. This is obviously better than nothing. It is a bash script. If you've got Windows, the Windows Linux subsystem, you can just run it there. Obviously, if you're on something that's got bash, you can just run it there as well. But it is worth noting out, and again, this will be in the repository. If PowerShell is your thing, I did do a pretty quick and dirty conversion over to PowerShell. So with this script that I've got here, let me get rid of those panels. It's pretty much the same thing. It's a PowerShell script. At the top here, we've got a bunch of environment variables. So you can see I've filled this out with things that make sense for my environment. I've got the region and subscription ID. I've got the names of things like the resource group, the VNet, and the subnet, all of which in my case exist already. And then I've also, importantly, I've put in that database ID there from GitHub that we just retrieved a few moments ago with that curl command. So that's where the database ID comes into it. It's worth noting out just really quickly as I scroll down, I have commented out a few things like I don't need to create a resource group, I don't need to create the subnet, and I don't need to create the virtual network. So I have commented out a few things. The few things that it is doing that's important is it's deploying the network security group, it's registering the GitHub.network provider in my subscription, it is then delegating the subnet to GitHub.network/network settings and applying the NSG to that subnet. And then down here, this is where it's deploying a resource of the type GitHub.network/network settings. And you'll see this here in a moment when we run this script. Actually, I should kick this off and then we can keep working through it. So let me bring up the terminal here and let's kick off GitHub preparation.ps1. That's going to need me to log into Azure. Just in the web browser here, I should be logged in already. Yep, beautiful. That is logged in. So I'll let that run in the background, although I have pretty much explained the whole thing. But it is worth noting that this network settings resource, that is the key resource inside of Azure that is going to allow this connection between GitHub Actions and the Azure virtual network. So the network settings resource is the resource that's got the GitHub organization ID in it, and it's the thing that's basically the broker between GitHub and the Azure virtual network. And as I scroll down here through the code, I think that that's pretty much it. Yep, there's just some outputs to do some cleanup. So that's going through the bicep deployment of the NSG right now. And then it will run those other Azure CLI commands to set up the configuration of these other things. So we'll just give that a minute or two. Awesome, that's finished up. And in the output here, there is something that we need. And it is this GitHub ID that it's output for the network settings resource. So this long string here, you'll need to copy that to your clipboard or just make a note of it because that ID is something that we need in the GitHub configuration that we're going to do in just a moment when we set up this networking configuration inside of GitHub. So for now, if I clear the screen, let's just jump back over to the Azure portal real quick. I'll do a refresh of the resource group and show hidden types. Just really quickly, I'm going to point out that we have got a network security group that's been deployed down here. And there also is this network settings resource. Now, if you need that ID that we just copied a moment ago, you can come into this network settings resource, and it is a tag value down here. So it's GitHub ID, and it's got the value in there. So if you didn't have it in the output of the script for whatever reason, you can come and grab it from here. And the other thing to note is that down here under the properties, you'll see that it is delegated to the specific subnet that we specified in that script that we just ran. And the business ID down there is the database ID of my GitHub organization that we retrieved a few steps ago. So that's how this whole integration kind of works, and the delegation to this type of github.network/network settings. So with that is everything on the Azure side of the house that we need to do to prepare. We've gotten the database ID, we've deployed what we need. So the rest of the configuration is pretty much across inside of GitHub. So let's go back to the main GitHub page here. Oops, I'll go into my organization. And where this is done is inside of the organization. If you go to settings and then scroll down, as long as you're on a team or enterprise plan, you will see this option here for hosted compute networking. And this is where pretty much the rest of this configuration is set up. So we've got no network configurations added right now. So we do need to add a new network configuration, and you'll see from the list, we've got Azure Private Network. So that allows us to connect the Azure Virtual Network to align hosted runners with your network policies. So over here for the configuration name, I'll call mine Azure VNET Runner Integration. It doesn't matter too much what it's called. And from here, we need to add an Azure Virtual Network. Now, you might be inclined to put in a resource ID of the subscription or of the subnet or the virtual network or something like that. But in fact, what we need to supply here is that long string that we had that was an output of the network settings resource ID. So remember back over, whoops, I've cleared the screen. You know what I mean. It was output with the script. I showed it to you in the interface. And when you click away from it, you'll see that it goes and looks up all of the other settings. So it says, yep, that resource ID is valid. I can connect to that subscription. Here's your subscription ID, your virtual network, subnet, so on and so forth. So we can add the Azure Virtual Network there, and this caught me out the first time. Once you've added it, there is actually a create button. So you need to create the configuration here. So don't navigate away from that page. That all looks good. So right now we've got the Azure Virtual Network configuration, but we don't have any runner groups that are configured that are using the configuration. So we need to create a new runner group inside of GitHub. Right here under runner groups, you can see there is the default runner group. So that, let's go and have a look at it actually. So this is the GitHub default runner group that's deployed basically with every organization. And interestingly, you can see down here, there's no network configurations. All repositories can access it. And this is the one that will be used if you use any of the default labels, such as over here. If we go and have a look at my workflow right now, Ubuntu.latest, it will go and pick up a runner from that default group right now. So if we go back to runner groups, we need to create a new runner group. And for mine, I'm going to call this Azure-VNet-runner-group. And you can choose which repositories can access and leverage this runner group. So here you can say, I've got selected repositories, and then you'd click on this little cog, and you can say which specific repositories that you want to have access to it. Or you could say, allow all repositories, and then you've got a checkbox as to whether or not to allow public repositories or not as well. So I'm going to say selected repositories, and I'm going to specifically select the repo that we're working in here. And the key thing to point out that you need to do here is this network configuration. So this is going to select the network configuration for this runner group. So under this configuration, the only one that we've got is the Azure VNet configuration that we just created now. So I'll go ahead and create that runner group. And then the runner group is all good, but we've got 0 runners inside of that runner group. So the final step of all of this is to go ahead and create a new runner, which is a member of this runner group. And that is the runner that we will then use in the workflow configuration. So down here, I can create a new runner, which is going to be a new GitHub-hosted runner. Again, this is not a self-hosted runner. This is not one that I'm having to manage or anything like that. It is fully managed by GitHub. So for the name of this one, I'm going to call this Azure-Linux-Runner. So I'm going to use a Linux platform for the runner, and I'll save that. For the image here, you could use the GitHub-owned images. So as it says here, these are kept up to date and secure, and it contains all of those tools that you get on the runner images by default. So there might be a few things that you need to install depending on what you're doing, but there's a bunch of tools and pieces of software and things like that that are available on those. You do also have the ability, if you wanted to use a partner image. As you can see right now, that's pretty limited specifically to NVIDIA GPU optimized images. So we definitely want to use the GitHub owned one. Ubuntu latest is absolutely fine for us, so we'll go ahead and save that. And then these are those specifications that you can choose for what GitHub call their larger runners. So if you needed more memory or CPU or disk space on your runners, you can choose the size here that you need. Do bear in mind again that these are going to cost additional runtime money above and beyond what you get included in Actions in your specific GitHub plan. So the higher spec you go, the higher the cost will be. And you'll actually see that here in a moment when I create this. I'm going to leave mine on 2 core because that's more than enough for what we're trying to do here. We want to add it to the Azure VNET runner group that we just created. So that's correct. And that is pretty much it. So we can go ahead and create that runner. When I create this runner here, it is going to tell me that there's an issue because the runners are shut down due to spending limit caps being reached. And it's telling me to try raising the Actions spending limit to continue using these runners. So I'll show you where that is in just a moment. We'll go to the billing page in a new tab. Over here in the organization under billing and plans, if I scroll down a little bit, you'll see here we've got usage this month for Actions. And specifically down the bottom here, there is a specifically down the bottom here, there is a $0 monthly spending limit, which basically means don't spend any extra dollars on Actions and don't bill me for any of it. So what this wants us to do is, because we need to basically spend more money to leverage these larger runners, we need to put a limit in here. Now you could go unlimited if you're really bold. I'm not. So I'm going to limit the spending. And for the sake of this, I'm just going to set that to $5 and update the limit. If I scroll back down now, where are we? We can see here under Actions and Packages, we have limited the spending to $5. Now what I found, if I went back over here to the Azure Linux runner, if I go ahead and refresh this, I'm not sure if there's just a period of time maybe that you need to wait, but you can see it is still shut down and it's still got that error message at the top. So I wanted to show this to you because I wanted to be really specific about the fact that this is going to cost additional money and it's not going to use the Actions minutes from your plan. So what I'll do really quick is I'm going to remove this runner from the organization and I'll go through the process of setting up a new runner again. And I'll do this really quick because we've already gone through it once. So I'll just do it again now and speed this up. And you can see now because I have increased, the spend limit, this runner is now in a ready state. It is ready to go. It's running Ubuntu latest. It is GitHub hosted. We can see the specifications over here of the runner. And we can see if there were any jobs running, we could see that information here. And you'll notice the other thing to be aware of over here under labels is the label for this one is specifically Azure-Linux-Runner. So that is the configuration that we'll need to put in our workflows to tell GitHub, hey, when this workflow runs for GitHub Actions, go ahead and use this runner. Don't use your default ones. I need you to use this one because this is the one that's connected to my Azure Virtual Network, and that's the connectivity that I need. So with all of that done and out of the way, we'll jump back over to Visual Studio Code here. I think we've gone through everything. Let's go and test it out. So let me get rid of the, I do that all the time. Let me get rid of these panels here. Actually, we need the one on the side back. Keyvault-YAML. And what we want to do is instead of running it on Ubuntu-latest, we simply want to run this workflow on Azure-Linux-Runner. So that is the label that we just saw in the GitHub user interface. And apart from that, we don't need to do anything else. So I'm going to save that YAML file. And then let's bring up our terminal down the bottom. We'll just do a git status, make sure that's all good. I changed the NSG as well, that's fine. So we'll do a git add, git commit, and we'll say changed workflow to run on Azure VNET integrated runner. And we'll do a git push to push that change up into GitHub. Awesome, let's clear the screen there and let's go and test this out. First of all, what I'll do over in the Azure portal, let's go and have a look quickly at the virtual network. And let's specifically look at connected devices, and I'll just leave this up. So at the moment, the connected devices is just that private endpoint for the key vault. So I'll keep this up here and we'll refresh this in a moment. We'll jump back over into GitHub and go back to our repositories, into the GitHub-hosted runner repo where I've been working, and go into Actions. Remember I showed you at the start that this failed, and it failed because it couldn't access the key vault. So let's go ahead and we'll trigger this manually. If I run the workflow, you'll see those inputs that I had just so I don't have to enter anything. But if you were following along, you've probably got a different name for your secret and a different name for your key vault. But that is all ready to go. So I'm going to run that workflow now. And we should see that kick off here just in a moment. There it goes. The run has started manually. So let's go into this workflow. And if I jump back over into Azure and just do a refresh on the subnet, it's not yet. We might just need to give it a minute or two as it kind of initiates the job. Let's have a look here. It's doing the pre-setup of Azure CLI. It's probably started to deploy those network interface cards. No, not yet. We'll just give it another minute or so here. This is actually the exact issue that I saw when that network security group wasn't allowing outbound traffic. So I'm wondering if I ended up saving that bicep file. Let's have a look at the network security group real quick and see if we've still got that outbound deny in place. No, we don't. I think we're allowing outbound to the internet through that default rule. We're denying inbound. That's all good. Okay, no, it's just taking a few moments. There it goes now. It was going to make a liar out of me. Let me go back into the virtual network and have a look at connected devices now. And we still don't have any network interfaces, okay? I've done something wrong here. This is excellent because I'm kind of glad that I did this. What have I done? Okay, it's still giving me a connection is not in an approved private link and the caller was ignored. It's like it tried to use the public internet again. I've done something silly here. Let's just go and have a look at what I've done. We're on the main branch. I didn't create any other branches. Runs on Azure Linux Runner. So it should be running on the right group. Let me go ahead and check the settings here. Oops, we need to go back to the organization and settings. We've got our VNet runner integration. That looks okay. That is using this group here. It's allowing my repository to use it, which is fine. It's integrating with the Azure VNet configuration. There are no runners configured. Did I fail? I mustn't have actually created the right runner or put it in the right group. Maybe I didn't put it in the right group. Let me go ahead and create this again. Actually, let me just check the runners that I've got. Have I got one that I need to delete? Oh, look at that. Silly me. I put the runner group in the default, not in the new runner group that we had that was integrated with the Azure Virtual Network. So let me go ahead and remove this runner. Look at that, nothing like a live demo with something that I've already gone through and I still managed to muck up is there. So that's just deleting that runner now. We'll go ahead and recreate the runner and actually assign it to the correct group. So this is a good thing to remember actually. So it is the runner group that you create in GitHub that is associated with the Azure Virtual Network integration, and it's not the runner itself. It is something to be aware of. Totally planned by me, by the way, just to reiterate this point, 100%. Let me give that a refresh. It looks like it was still deleting. I'll give that a minute or so. Hey, this is Future Matt here. Just as I was editing the video, I'm about to go through the process of deleting and recreating that runner, but I did also want to call out, I'm just here in GitHub and I'm back on the under Actions, and I'm looking at runners here, and we can see that we've got the Azure Linux runner. I did want to point out, rather than deleting it and recreating it like I'm about to do, I could have just come into the settings here to edit the runner, and then simply just changed which runner group it's associated with in here. So it was on default, and I could have just switched it across to the group here. Just wanted to add that in. I didn't necessarily need to go through the process of deleting and recreating, but anyway, that's what I did, so let's continue on. There we go, that runner's been deleted. So let me create a new runner. It's going to be a GitHub hosted runner. I will call it Azure Linux runner. It's going to be Linux, GitHub owned image of Ubuntu latest. It's going to be a 2-core, that's absolutely fine. And importantly, the runner group here needs to be the Azure VNET runner group, not the default. So let's go ahead and create that runner. And that should only take a second to spin up. There we go. And it is ready for use. That looks good. Let's jump back across to our repository. We don't need to update anything with the actions because it's still using that same label that we had before. So let's go into Actions, into this one, and run that workflow, and let's kick it off. And we'll give that a second or two just to start the workflow here, and we'll jump in and watch it as it goes along. There it starts now. So we'll jump into that job that's just started too, and it's waiting for a runner to pick up this job. What we'll notice now, I'm sure, is if I come back over here and refresh, there we go. That is exactly what I was expecting to see. So these network interfaces are being deployed by the GitHub Actions service. So we don't see the virtual machine or the container or any of that. That's all still managed and hosted by GitHub. We're not paying for any compute specifically in our Azure environment or our Azure subscription. All we are seeing are these network interface cards that pop up on the subnet. That's all we're seeing. So it looks like that job is still waiting for a runner to pick it up. So I'll give this a few seconds to run through and we'll take a look. All right, there we go. That has run through and I've got the green tick, so that is looking good. Let me just go back to the job here and we'll refresh this. So it was able to retrieve the secret from the key vault. You noticed before that was the step that it was failing on before, so that looks good. And then if we displayed the secret, look at that. If I zoom in a little bit here, this is only for demonstration purposes, remember, but it does say here, whoops, that's popped up again. It does say here the secret is, and that string that I punched in when I first created the secret inside of Key Vault. So it was able to retrieve that from the private endpoint by using the virtual network integration. It was able to retrieve our secret from the Key Vault and then print it back on screen to us here in the workflow. Obviously, you wouldn't normally do that. If you were retrieving a secret, you'd then pass it into a bicep template or into some other configuration, depending on if you're doing a database deployment or writing out to some Azure storage or whatever it is that you're doing. So that is pretty much it. I think that's all I had for the demo. We did get it to work in the end because I was trying to go too fast when I recreated the runner the second time and I put it on the wrong runner group. So as long as you do everything correctly, it should work pretty well. And like I said at the start, I'm pretty excited by this functionality. We've got a lot of customers that have gone down the route of using self-hosted runners, and there's just a lot of pain that comes with that, whether it's auto-scaling, whether it's needing to keep images up to date yourself, whether it's just paying for the cost of that, the compute cost and hosting it, so on and so forth. There are just some pain points that come with the self-hosted, and this is a really fantastic solution that GitHub and Microsoft have come up with to allow this to work. So again, this is all GitHub hosted. There's no management for you to worry about, and you don't necessarily need to worry about the images. You can access private resources, whether that be on your Azure virtual network, whether it's another virtual network that's peered to the one that you set up for this GitHub integration, or even across a hybrid environment down to an on-premises environment through an express route or a VPN, so on and so forth. As long as there's IP connectivity and it's allowed through your firewalls and things like NSGs and your routing set up correctly, then it will all work as expected. And just remember, obviously go back through this video if you need to, but you do some configuration in Azure first to set it up and get that network settings resource set up, input the GitHub database ID into there, and then the rest of the configuration is done across in GitHub, where you set up the network configuration, you set up the runner group, you go and create a runner, and then in your workflows, you specify that label of the runner that you want to use for your workflows. And just again, I know I've mentioned this a few times, but just do remember, because it is using larger runners for this configuration, it is an additional cost for the runtime of using these runners for this specific VNet integration. So An interesting thing and a final thought, I guess, to leave you with is the way that you design your GitHub Actions and your workflows. You might be able to still use GitHub's default runners for things like doing builds of your application. So it depends on what your requirements are, but you might still do a standard .NET build of your application using a GitHub-hosted runner, which will use those actions included in your plan. And maybe it's just the release that you need to do on the runner pool that is configured with Azure Virtual Networking. So you might be able to do a 10-minute build using the GitHub pool and then a quick release on these ones, and therefore lowering the amount of spend that you'll have on the actions consumption for these specific larger runners. So it's just something to think about as you go about designing your actions and your workflows. I hope this has been really useful. I need to wrap it up here because I've probably rambled on long enough. I hope that was useful. Again, chapters are below, all the references and the links are below. Leave me a comment if you've got any questions. I'd love to hear from you. Love to know if you are going to implement this functionality for yourself, your company, or some of your customers. And with that, thanks for watching. See you again soon.